Hi, this is Alex from devstories.eu. BMAD method, episode 10 of 15. Sometimes the full agile process is overkill for a localized fix. You have a messy Jira bug report and you just want it fixed and reviewed without manually verifying every step. Here is how to go from that raw ticket to a reviewed pull request in a single autonomous run using the quick-dev track for zero-blast changes. People often view quick-dev as just a generic code prompt where you throw a ticket at a large language model and hope for the best. It is not. Quick-dev explicitly isolates intent clarification from execution. It gives the system a hard boundary to work against rather than bleeding the problem definition directly into the code generation step. The standard agile track relies heavily on strict checkpoints. You pause, verify the plan, verify the tests, and verify the implementation. Quick-dev strips those checkpoints away. It trusts the model more and saves your human attention for high-leverage moments. You only use this track for zero-blast radius changes. Mechanically, this means modifications must be isolated to a single component or function. The change cannot alter public interfaces, modify database schemas, or rewrite shared utility functions used by other domains. If a change touches core state management, it belongs on the standard track. Consider the scenario where you pass a link to a fragmented Jira bug ticket into the bmad-quick-dev tool. The first thing the system executes is intent compression. It reads the scouted comments, the steps to reproduce, and the user complaints. It forces the model to resolve contradictions before touching any code. If the ticket has conflicting instructions, the compression step synthesizes them into a single definitive goal. This output is plain text, defining exactly what the fix entails and, critically, what the boundaries of the fix are. Here's the key insight. Because the intent is now compressed and isolated, the autonomous execution phase has a strict specification to follow. The system writes the fix, generates or updates the localized tests, and runs a self-review against that initial compressed intent. It loops through these steps continuously. You step away while it works, and you return to a finished pull request. Quick-dev is fast, but when an autonomous run fails, you must diagnose the failure layers accurately. You look at where the process broke. If the final code solves the wrong problem entirely, the failure happened at the intent compression layer. The Jira ticket was likely too ambiguous, causing the model to hallucinate the goal. You fix this by rewriting the initial input. If the intent is correct but the new tests fail or the builds breaks, the failure is in the execution layer. You fix execution failures by nudging the model to retry the specific logic block. If the execution layer fails twice in a row, the problem is no longer the prompt. The blast radius of the change was simply larger than you initially thought, and you must drop back to the standard checkpointed track. Autonomy only works when the boundary of the task is smaller than the context window of the model solving it. That is all for this one. Thanks for listening, and keep building.